Sci Sippers, welcome back to the binge-watching bonanza. Buckle up because we're about to embark on a cosmic cocktail adventure. An exploration of the weird and wonderful, a scientific smorgasbord that will tantalize your taste buds for knowledge. This is Sci Sips, your one-stop shop for all things science. And today marks a special occasion. It's the 15th episode of our binge-watch special. For the past 14 binges, we've delved into the heart of black holes, explored the mysteries of the deep sea, and even cracked the code of animal communication. But today, we're taking things to a whole new level. We're on a mission to unlock the universe's secrets, explore the wonders of nature, and even crack the code to happiness. First, we're peering into the future with a groundbreaking technology, LiDAR. But not just any LiDAR, we'll be diving into the breakthrough of Single-Photon LiDAR, achieved by the University of Science and Technology of China. This revolutionary advancement promises to create ultra-high-resolution 3D maps, with applications that could transform everything from self-driving cars to disaster relief. We'll explore how LiDAR works, the mind-blowing capabilities of single-photon technology, and the exciting possibilities it holds for the future. Next, we're taking to the skies to explore the secret magnetic sense of birds. How do these feathered friends navigate with such precision? It turns out, they possess a remarkable ability to sense the Earth's magnetic field. We'll delve into the evolutionary mysteries behind this magnetoreception, explore how birds use it for migration and navigation, and discover the potential applications for this fascinating biological phenomenon. Could this unlock new technologies for us humans too? History buffs and science enthusiasts, rejoice! We're on a journey to rediscover three genius greats of ancient Indian science. From the brilliance of Aryabhata, the mathematician who popped the concept of zero into existence, to the pioneering work of Sushruta, the father of surgery. Prepare to be amazed by the ingenuity of these ancient minds. We'll explore their groundbreaking contributions to mathematics, medicine, and astronomy, and see how their work laid the foundation for scientific progress. Ever wondered if we're alone in the universe? Buckle up as we explore the bizarre phenomenon of spiders on Mars. Well, not exactly spiders, but the Martian areniform terrain, creepy, crawly rock formations that resemble spiderwebs. We'll delve into the mysteries surrounding these structures, explore the possibility of past water on Mars, and uncover the ongoing search for extraterrestrial life. Could these spiders be a sign of something more? The cosmos holds many a dramatic tale, and today, we're witnessing a celestial whodunit. Did Jupiter murder Earth's sister? We'll travel back in time to explore the hypothesis of a giant impact between a planet called Theia and our very own Jupiter. This cosmic ballet might have led to the formation of our moon. We'll explore the evidence for this theory, the dramatic events that could have unfolded, and the ongoing quest to understand our solar system's origins. Feeling a little down? We've all been there. But what if science held the key to unlocking happiness? We'll embark on an epic neurobiological journey to understand the science of happiness. From the role of neurotransmitters to the power of positive thinking, we'll explore the science behind happiness and share 3 practical steps you can take to boost your mood and cultivate more joy in your life. Buckle up, physics enthusiasts, because we're venturing into the bizarre realm of the Kapitza-Dirac Effect. Imagine a world where particles defy gravity and propel themselves upwards. The Kapitza-Dirac Effect is a mind-bending phenomenon that challenges our understanding of physics. We'll explore the theoretical underpinnings of this effect, the ongoing research to confirm its existence, and the potential implications it could have for our understanding of the universe. Finally, we're diving deep into the ocean's bioluminescent wonders to unravel the mystery of nature's neon glow. Have you ever seen a glowing jellyfish or a bioluminescent bay? We'll explore the fascinating world of bioluminescence, the different ways marine creatures produce light, and the ecological reasons behind this dazzling display. Is bioluminescence just a pretty light show, or does it play a vital role in the ocean ecosystem? 8 mind-blowing scientific explorations in just 1 hour. Are you ready to quench your thirst for knowledge and explore the strangeness and wonder of science? So grab your favorite beverage, settle in, and get ready for an epic Sci Sips binge-watch adventure. Don't forget to like, comment, and subscribe for more science shenanigans. Let's dive in.
In the quiet corridors of the University of Science and Technology of China, or USTC, a team of physicists is altering our perception of the microscopic world. as they successfully developed a groundbreaking single-photon LiDAR system. They achieved resolutions once thought to be the stuff of science fiction. This technological leap isn't just a step, but a giant leap in high-resolution imaging technologies, potentially unlocking unprecedented capabilities in various fields including physics, biology, and environmental science. LiDAR, or light detection and ranging, is a method for measuring distances by illuminating a target with laser light and measuring the reflection with a sensor. Conventional LiDAR systems emit thousands of photons per pulse, sufficient for macro-level measurements, like topographical mapping. However, USTC's implementation of single-photon sensitivity in LiDAR technology introduces a significant enhancement in both the sensitivity and resolution of these measurements. The essence of single-photon LiDAR lies in its capacity to detect and record the arrival of individual photons reflected from objects, even at vast distances. This high sensitivity allows for finer discrimination of the target's properties, such as composition, texture, and microtopography, opening up new avenues for microscopic analysis. The advantages of this high-resolution imaging system are manifold. Traditional systems, while useful, often fall short in dense atmospheric conditions or in capturing minute surface details. Single-photon LiDAR, conversely, can penetrate challenging environmental barriers and provide data with a precision that was unimaginable until now. The innovation at USTC did not occur in isolation, but as a part of a broader endeavor to enhance optical technologies. Led by Professor Lin Qing, the team's approach was to refine the photon detection mechanism, thus improving the temporal resolution and reducing noise at very low light levels. Their breakthrough was achieved by creating a finely tuned optical system that couples advanced photon timing methods with sophisticated algorithms designed to reconstruct a 3D model from these single photons. The implementation involved an intricate calibration of the LiDAR's components, especially the detectors and the laser source. The result was a system that could operate under a variety of environmental conditions, reliably producing high-quality, high-resolution images. Furthermore, it demonstrated an exceptional ability to distinguish between multiple closely spaced surfaces, a capability crucial in complex scientific experiments and precision engineering. A significant aspect of the breakthrough lies in its scalability. The USTC team has designed the system not just for large-scale laboratory experiments, but with the potential for adaptation in portable devices, promising wide-ranging applications in both research and commercial sectors. The immediate implications of high-resolution single-photon LiDAR are profound in fields where precision and resolution are paramount. In physics, the ability to detect subtle changes in physical environments can lead to new insights in particle physics and quantum mechanics. For engineers, especially those working in robotics and autonomous vehicles, the enhanced detection capabilities mean improved obstacle identification and navigation precision. Moreover, this technology has significant implications for environmental science. Its ability to capture detailed topographical data, even in adverse weather conditions or through forest canopies, makes it an invaluable tool for ecological surveys and climate change studies. Looking ahead, the potential applications of single-photon LiDAR extend beyond the laboratories and into everyday life. Its integration into consumer technology could lead to enhanced safety features in vehicles, more precise medical imaging techniques, and even transformation in how we interact with our digital environments. The societal implications are equally vast. As our ability to perceive and understand the microscopic details of the world around us improves, so too does our capacity for making informed decisions about environmental policy, urban planning, and public health. The technology presents ethical considerations as well, especially regarding privacy and surveillance, necessitating thoughtful discourse on its deployment. In summary, USTC's advances in single-photon LiDAR technology represent a pivotal milestone in our journey to unravel the mysteries of the physical world. This new tool not only enhances our scientific and engineering capabilities, but also promises to play a critical role in shaping the future trajectory of multiple disciplines, potentially leading to a deeper, more nuanced understanding of the universe. Thanks for joining us on this scientific adventure today. If you enjoyed unraveling the mysteries of LiDAR, let us know by giving this video a thumbs up and subscribing to Sci Sips for more science fun.
Ever wondered how birds navigate across continents with such precision? They're not just following breadcrumbs. New research reveals a hidden superpower birds possess, a built-in compass. That's right, some birds can actually sense the Earth's magnetic field, guiding them on epic journeys. But how does this work? And why don't all birds have this amazing ability? Buckle up, because we're about to dive into the fascinating world of avian magnetism. Imagine soaring high above the Earth, the vast landscape spreading infinitesimally below, navigating over continents and oceans with precision comparable to the most sophisticated compasses. This isn't a feature from the latest high-tech drone, but rather, a day in the life of migratory birds.
Equipped with a biological marvel known as the magnetic sensor, birds exploit the Earth's magnetic fields to embark on some of the most awe-inspiring journeys in the natural world. The unraveling of how birds' magnetic senses have been finely tuned by evolution remains one of the most tantalizing mysteries in the realm of evolutionary biology.
As these feathered navigators crisscross the globe, scientists have been diligently peeling back layers of this intricate biological system, revealing not just how it works, but why it evolved so distinctively. This video endeavors to explore the depths of magnetoreception, a sense as mysterious as it is crucial to the survival of countless avian species. Birds' magnetic sense, or magnetoreception, allows them to perceive Earth's magnetic field, thus facilitating phenomenal migratory feats. The complexity of this sensory system is a puzzle that has captivated scientists for decades. Recent research reveals that this ability is likely mediated by a protein called cryptochrome, located in the retina. This protein is thought to form the basis of a chemical compass, enabling birds to see magnetic fields as patterns of light or darkness. The protein cryptochrome reacts to magnetic fields, suggesting a light-dependent mechanism wherein the magnetic information is possibly superimposed on the bird's normal vision. This dual functionality not only emphasizes the elegance of evolutionary adaptations, but also exemplifies nature's efficiency, integrating new capabilities with existing systems. Understanding this system's function requires a multidisciplinary approach, combining ornithology, quantum chemistry, and neurobiology. The fusion of these fields paints a picture of evolution not as a linear path, but as a dynamic, interactive process where survival needs drive the development of biological complexities like magnetoreception.
The evolutionary origins of birds' magnetic sense are as fascinating as they are complex. It is believed that magnetoreception evolved early in the avian lineage, an adaptation that likely provided a significant evolutionary advantage by enhancing navigational abilities, crucial for migration, territorial mapping, and even day-to-day survival. Fossil records and genetic data suggest that the ancestors of modern birds, some dating back to the age of dinosaurs, might have possessed primitive forms of this sense, which were refined over millions of years. Studies of Archaeopteryx, a transitional fossil between non-avian dinosaurs and birds, indicate the potential presence of structures that could support magnetoreception. This hints that the trait was not just an evolutionary fluke, but a pivotal feature selected for its profound impact on survival. The refinement of magnetoreception in birds is a classic example of evolutionary innovation, where existing structures and senses are repurposed and enhanced. This process, known as exaptation, involves the gradual transformation of a feature serving one function into a feature that serves another. An understanding of this evolutionary process provides not just insights into the past, but also illuminates possible future adaptations in response to changing environmental conditions. Animal technology goes way beyond just bird magnetism. Here are some other incredible examples of how animals have evolved amazing tools to navigate and interact with their environment. Sonar in dolphins and bats. These creatures don't rely on sight for close-quarters navigation. They emit high-frequency sounds, clicks for dolphins, squeaks for bats, that bounce off objects, giving them a detailed picture of their surroundings. This biosonar is so precise, dolphins can even identify the size and shape of their prey. Electric reception in sharks and rays. Imagine having a built-in metal detector. Sharks and rays have a special sense called electroreception that allows them to detect weak electrical fields emitted by living organisms. This helps them find hidden prey buried in sand or navigate murky waters. Infrared vision. In snakes. While some snakes can see like us, Pit vipers have a special heat-sensing organ on their face. These pits detect infrared radiation, allowing them to see warm-blooded prey in complete darkness. Imagine a snake using a night vision camera built right into its head. Echolocation in swiftlets. These amazing birds navigate caves and hunt insects in complete darkness using echolocation, similar to bats. But unlike bats that use sound, swiftlets emit high-pitched clicks and listen for the echoes to locate their surroundings. Polarized light. Vision in bees. Bees can see ultraviolet light and a special type of light called polarized light, which is invisible to humans. This helps them navigate using the sun's position, even on cloudy days. It's like having a built-in compass and map all in one. These are just a few examples of the incredible technologies animals have developed. It's a constant reminder of the amazing adaptations that evolution has produced in the natural world.
By unearthing these evolutionary secrets, this video not only heightens our understanding of bird navigation, but also underscores the intricate dance between organism and environment. A perpetual interplay of challenges and adaptations where only the most finely tuned survive. This exploration of avian magnetoreception not only adds a chapter to the story of evolution, but also enriches our appreciation of the natural world's complexity and the delicate balances sustaining life on Earth. If you found this fascinating, smash that like button and subscribe to Sci Sips for more science adventures in bite-sized chunks. Let me know in the comments what other animal superpowers you're curious about. There's a whole world of scientific exploration waiting for us.
Forget everything you think you know about ancient civilizations. Today, we're journeying to a land of forgotten giants, where scientific minds blossomed centuries before their Western counterparts. We're heading to ancient India, and we're not here for yoga retreats or spicy food, though those are great too. We're here to crack open the vault of history and unearth groundbreaking discoveries that change the course of science forever. From pioneering surgeons who performed the world's first plastic surgery to mathematical geniuses who invented the concept of zero, ancient India was a hotbed of innovation. Prepare to have your mind blown as we explore deeper. Did you know that the concept of zero, a foundation of modern mathematics and science, originated from ancient India? Let's journey back to the era of the ancient Indian mathematicians who first grappled with the idea of nothingness, or shunya. This concept, which we now know as zero, was a radical idea that sparked a revolution in mathematics. In the realm of numbers, where everything had a value, the idea of something having no value was both revolutionary and perplexing. Ancient Indian texts, notably the Atharva Veda and the Bodhayana Sulba Sutra, hint at the use of a placeholder in mathematical operations. This placeholder was the precursor to the modern zero. However, it was the ancient Indian mathematician Brahmagupta who first documented rules for mathematical operations involving zero around the 7th century. His work, the Brahmasfuta Siddhanta, provided a robust framework for handling this intriguing number. Remember that some of these images are indicative and we may never know what these ancient greats really looked like. The concept of zero didn't just stay in India. It journeyed westward, carried by Arab traders and scholars who translated Indian mathematical texts into Arabic. This led to its adoption by the Arab mathematicians and subsequently its introduction to Europe. The concept of zero, as we know it today, was hence born, transforming mathematics and science forever. The genesis of zero is a testament to the intellectual prowess of the ancient Indian scholars. It's a reminder of their foresight and their ability to grapple with abstract concepts that were well ahead of their time. Indeed, without the concept of zero, modern science as we know it wouldn't exist. Up next, surgery in ancient India. Sushruta, an ancient Indian physician, is often referred to as the father of surgery. But why? Well, let's delve into the annals of history and unravel the tale of this pioneering figure. Sushruta's significant contributions to the field of medicine, specifically surgery, are well documented in the Sushruta Samhita, an ancient medical treatise. This comprehensive text, written in Sanskrit, meticulously details over 300 surgical procedures and describes 120 surgical instruments, a testament to the advanced surgical knowledge of the time. From performing complex surgeries such as cataract and cesarean section to crafting prosthetic limbs made of iron and wood, Sushruta's surgical acumen was truly ahead of its time. His detailed study of human anatomy, his emphasis on the importance of cleanliness and hygiene in surgical procedures, and his innovative use of wine as an anesthetic all speak volumes about his forward-thinking approach to medicine. So, the next time you see a surgeon at work, remember Sushruta, the ancient Indian physician who laid the groundwork for this life-saving discipline. Let's move on now to India's contribution to astronomy. Imagine calculating the approximate value of pi and the length of the solar year over a millennium ago. Sounds impossible? Not for Aryabhata. In the early days of the 6th century, a man named Aryabhata was making groundbreaking strides in the field of astronomy. His contributions to the world of science were nothing short of revolutionary, and his name continues to echo through the halls of astronomy and mathematics even today. Aryabhata's work on the approximation of pi was a marvel of ancient mathematics. He proposed that the value of pi was approximately 3.1416, and while this might seem elementary to us today, it was a calculation of extraordinary precision for his time. This approximation of pi, an essential constant in geometry and trigonometry, paved the way for numerous advancements in the field of mathematics. But Aryabhata's genius didn't stop at mathematics. His astronomical calculations were equally profound. He calculated the length of the solar year as 365 days, 6 hours, 12 minutes, and 30 seconds. Amazingly, this is just 3 minutes off from the actual value recognized today. Aryabhata's work is a testament to the profound understanding of the cosmos that existed in ancient India. His calculations, while performed over a millennium ago, still hold true today, highlighting the advanced scientific knowledge present in ancient Indian society. His legacy continues to inspire modern scientists and astronomers, reminding us that the quest for knowledge transcends time and geographical boundaries. From the concept of zero to groundbreaking medical and astronomical advancements, these ancient Indian scientific discoveries continue to influence our world today. We've delved into the genesis of zero, a concept so fundamental to mathematics and beyond, it's hard to imagine a world without it. We've explored the innovative surgical methods of Sushruta, the father of surgery, whose techniques continue to inspire modern medical practices. And we've embarked on a cosmic journey with Aryabhata, whose astronomical calculations opened up the heavens for study and understanding. These are but a few examples of how ancient Indian science has shaped our present and will continue to shape our future. If you enjoyed this journey into the scientific past of ancient India, be sure to give this video a like and subscribe to Sci Sips for more fascinating insights into the world of science.
Mars. A barren wasteland, frozen in time. Or is it? They say there's no life on Mars, but what are these strange crawling shapes? Prepare to have your mind blown as we reveal the truth behind the Martian spider invasion. That isn't actually an invasion at all. We've all seen the iconic images of Mars, the rusty red landscape, the rovers exploring the dusty plains. But what if Mars held a hidden secret? A secret not of little green men, but of a dynamic and surprising natural phenomenon. Join us as we delve into the mystery of the Martian spiders and discover the truth behind these fascinating seasonal features. Amidst the cold, thin atmosphere of Mars, an enigma stretches across the alien landscape, almost taunting us from millions of miles away. Known as the Martian spiders, these dendritic radial troughs in the region dubbed Inca City are not the work of extraterrestrial arachnids, but highlight the profoundly unique Martian climate and geological activities. It's a phenomenon absent on Earth, presenting a puzzle that combines elements of geology, meteorology, and planetary science in a way that captivates scientists and spectators alike. As we peer at these intricate patterns through the eyes of orbiting satellites, they whisper secrets of the Martian past and perhaps clues to its future. Martian spiders, scientifically known as areniform terrain, encompass the star-like fissures seen predominantly in the planet's south polar regions. Unlike anything encountered on Earth, these features develop through processes tightly coupled with the peculiarities of Martian climate. Specifically, the seasonal deposition and sublimation of carbon dioxide ice. As winter casts a frigid blanket over the polar landscapes, a layer of CO2 ice conceals the surface. And during the spring, as the sun returns, sublime dramas unfold underneath this icy veneer. Punctuated by the contrasting red dust and stark white ice, these formations begin their life cycle when sunlight penetrates the translucent ice, heating the ground beneath it. The trapped carbon dioxide, turning from solid to gas, builds pressure until it bursts through the ice in a spectacle of Martian jet geysers, scattering dust and vapor. This cyclical process gradually carves the sprawling, dendritic channels over millennia, sculpting the peculiar areniform appearance that mystifies onlookers.
Experts like Dr. Candice Hansen from the Planetary Science Institute suggest that understanding these processes not only unveils aspects of Mars' current climate, but also provides hints about historical shifts in its environmental conditions. Studying areniform terrain is studying Martian weather in action, Hansen remarks, suggesting a dynamic connection between surface features and atmospheric phenomena. Inca City, a sector within Mars's south pole, stands out not only for its spider formations, but also for its complex geological makeup. While its name might evoke images of ancient earthly civilizations, this Martian region is far from habitable, shaped by forces quite alien to our common understanding. What adds to its intrigue is the suggestion that these spiders could provide insights into past Martian climates, including the possibility of water ice beneath the surface, which has profound implications for theories about life on Mars. What is evident from orbit is that Inca City is not a city at all, but rather an intricately layered deposit possibly formed through successive volcanic activities, mixed with dust and ice accumulation over eons. This layering offers a record akin to geological sedimentation on Earth, but shaped by Martian specificities, mainly its atmosphere and temperature swings.
Imaging spectrometers and radar data from missions like the Mars Reconnaissance Orbiter have shown that beneath the CO2 layer, there might be stratified water ice dating back thousands of years. Researchers believe that the unique thermal inertia observed in the Inca City region could point towards interactions between the surface and subsurface ices and the atmosphere. This relationship can potentially mimic a climatic record, much like rings of a tree tell the story of its growth conditions year by year. As Michael Mellon, a researcher involved in the MRO's missions, points out, these ice layers appear to preserve a record of climate changes on Mars, much like ice cores do on Earth. Hence, Martian spiders are not just curiosities. They're clues in deciphering the planet's climatic history, thereby enriching our understanding of whether conditions might once have been favorable for life.
Our solar system is full of strange and unexpected phenomena. Here are a few bizarre occurrences on other planets that rival the Martian spider vents. Venus's upside-down rotation. Venus spins in the opposite direction of most planets in our solar system, meaning the sun rises in the west and sets in the east. This slow, backward rotation creates a day on Venus that's longer than its year. Uranus's tidal axis. Uranus is a giant gas planet tilted on its side by nearly 90 degrees, making it appear to roll on its side around the sun. This extreme tilt causes its seasons to be extreme as well, with each pole experiencing decades of sunlight, followed by decades of darkness. Jupiter's Great Red Spot. This swirling storm on Jupiter is a monster. It's been observed for centuries and is bigger than Earth. The exact cause of this persistent storm remains a mystery, but it's thought to be fueled by the planet's powerful internal heat. Saturn's Hexagonal Storm. At Saturn's North Pole lies a bizarre, six-sided jet stream unlike anything found on Earth. This persistent hexagon is hundreds of kilometers wide and spins at incredibly fast speeds. Scientists are still working out the exact cause of this fascinating geometric weather pattern. Neptune's Dark Spot. Similar to Jupiter's Great Red Spot, Neptune has a giant dark storm system, nicknamed the Great Dark Spot. This anticyclonic storm appears dark because it's colder and higher in altitude than the surrounding clouds. These are just a few examples of the weird and wonderful things happening on our neighboring planets. As we continue to explore our solar system, we're bound to discover even more bizarre and fascinating phenomena.
Let's summarize what we saw on Mars. In a landscape as alien and desolate as Mars, these spiders offer a reminder of the planet's dynamic and ever-changing environment. Each spring, as the Martian ice crackles and gives way to erupting plumes of CO2, we catch glimpses of processes that, while starkly different, remind us of Earth's own seasonal rebirths. The Martian spiders, eerie yet fascinating, serve not only as subjects of scientific inquiry, but as symbols of ongoing exploration, capturing our collective imagination and propelling our understanding of the Martian environment to new heights. Thanks for joining Sci Sips on this wild ride to Mars. Before you blast off to your next adventure, hit that like button to let us know you enjoyed learning about the truth behind the Martian spider invasion. And if you're thirsty for more mind-blowing science, be sure to subscribe for a weekly dose of spacey exploration and earthly discoveries.
Billions of years ago, in the violent ballet of a young solar system, a cosmic dance turned deadly. A Mars-sized world, ripped from its orbit, hurtled towards a collision course with Earth. But this wasn't just any impact. This was a planetary brawl of epic proportions, a cataclysm that would reshape our world and give birth to a celestial companion, the Moon. Buckle up, because we're about to rewind time and explore the incredible story of how Jupiter yeeted a planet into Earth, and in the process, accidentally gave us the Moon. When the cosmos orchestrates its elements, it sometimes does so with a grandeur that outshines even the wildest human fables. In our celestial neighborhood, a pivotal act of this cosmic ballet occurred over 4.5 billion years ago, involving Jupiter, an errant planetesimal named Theia, and the nascent Earth. This cosmic encounter, underpinned by a delicate interplay of gravitational forces, led to one of the most significant events in the history of our planet, the birth of the Moon. But how exactly did these distant, seemingly unlinked celestial bodies conspire to create Earth's only natural satellite? As we delve deeper into the mechanics of our solar system's formation and evolution, the story becomes not only clearer, but also more enthralling, challenging our understanding of planetary creation and destruction.
Dubbed the behemoth of our solar system, Jupiter's role extends far beyond its colossal size and magnetic dominance. Its formation and subsequent migration through the solar nebula played a fundamental role in shaping the orbital dynamics of the minor planetary bodies that existed in the early solar system. The narrative begins as Jupiter, likely taking shape in the frosty outskirts of the young solar system, started its inward journey, drawn toward the Sun by intricate gravitational interactions with the gas and dust around it. As this giant planet migrated inward, its immense gravitational field acted like a cosmic bulldozer, clearing its path of smaller debris and influencing the orbits of countless other nascent planetary bodies. Astrophysicists believe that Jupiter's migration not only shaped the architecture of the outer solar system, but also set the stage for dramatic events closer to the Sun. One of these influenced bodies was Theia, a Mars-sized planetesimal whose destiny was intricately tied to Earth's. While Jupiter's story is one of creation and destruction, influencing the birth of planets and the ejection of debris, its indirect influence on Earth's tail is a testament to the interconnected nature of celestial mechanics. The giant planet's gravitational disturbances precipitated the eventual migration of Theia towards the inner solar system, setting the stage for one of the most significant impact events in Earth's geological history.
The equilibrium of the early solar system was delicate, a ballet of celestial bodies, each moving according to the gravitational symphony composed largely by Jupiter. Theia, nudged from its initial orbit, found itself on a catastrophic collision course with Earth. This event is not merely a footnote in Earth's history, but a defining chapter in its developmental saga. This colossal impact, hypothesized by the giant impact hypothesis, is believed to be the mechanism behind the formation of the Moon. According to recent simulations and isotopic studies, when Theia collided with Earth, the impact was of such magnitude that it liquefied much of the young Earth's crust and mantle, ejecting a significant amount of debris into orbit around Earth. This debris, a mixture of materials from both Theia and Earth, eventually coalesced under its own gravitational pull to form what we now know as the Moon. This process, marked by cataclysmic violence, highlights the chaotic nature of planetary formation and the fine line between destruction and creation. Further insights into this event have been provided by more detailed analyses of lunar rock samples returned by the Apollo missions. These analyses reveal similarities in the isotopic compositions of the Earth and the Moon, suggesting a common origin. They subtly underscore the scenario in which Theia, initially an independent world possibly formed at a different location in the solar system, became an integral part of the entity that is now Earth-Moon system.
Here are two other awe-inspiring facts from our solar system. The Symphony of Auroras. Imagine a celestial light show so vast and vibrant it takes your breath away. That's the beauty of auroras, the dancing curtains of light that paint the night sky in greens, pinks, and violets. But this isn't just a pretty picture. Auroras are a result of a cosmic ballet between Earth's magnetic field and charged particles from the Sun. As these particles get funneled down the magnetic field lines, they collide with atoms in our atmosphere, releasing bursts of colorful light. It's a stunning reminder of the interconnectedness in our solar system, the underworld ocean on Titan. Our solar system isn't all barren rock and gas. Saturn's moon, Titan, holds a secret beneath its icy crust, a vast ocean of liquid hydrocarbons, like methane and ethane. This hidden sea is bigger than all of Earth's liquid water combined. Scientists believe this ocean could harbor the potential ingredients for life, even if it wouldn't look like life on Earth. The idea of a whole other world with a hidden ocean, bathed in the faint light of Saturn, is a mind-boggling glimpse into the diversity of our solar system. Here are 3 conspiracies about the moon's formation and some scientific debunking. Conspiracy theory. 1. Artificial moon. Claim: the moon is a giant hollow space station built by an alien civilization. Contrast with facts. The moon's composition, as analyzed from lunar samples, closely resembles Earth's mantle, suggesting a common origin. The moon also lacks any features or artificial materials indicative of alien construction. Conspiracy theory 2. Second sun theory. Claim: the moon was once a second sun orbiting Earth, but it cooled down and became a moon. Contrast with facts. Stars like our sun generate immense heat through nuclear fusion. There's no evidence the moon ever possessed the necessary mass or internal structure for such a process. Conspiracy theory 3. Captured moon. Claim: the moon wasn't formed with Earth but was captured by Earth's gravity millions of years ago from wandering through space. Contrast with facts. The moon's orbit and composition strongly suggest a formation alongside Earth. The giant impact hypothesis explains the moon's formation from debris of a collision.
Before we go, let's quickly recap. The story of Theia and its terminal encounter with Earth, orchestrated by Jupiter's gravitational influence, offers profound insights into the processes that shaped our solar system. It reminds us of the fluidity of cosmic events, where beginnings are often clad in the remnants of endings. The formation of the moon was not only a result of cosmic violence, but also an event that would eventually make Earth a more stable and habitable world, influencing the emergence and evolution of life. In this cosmic ballet, the roles of Jupiter and Theia were crucial. Jupiter, the great orchestrator, indirectly engineered events that led to the moon's creation. Meanwhile, Theia's devastating final act, its sacrifice, provided Earth with a natural satellite, crucial for maintaining the balance necessary for life. Together, their story is a stellar example of how cosmic forces come together in the vast, dynamic theatre of the universe to choreograph events of monumental scale and consequence, shaping not just planets, but the possibilities of life itself. Before we blast off, let's fuel up your curiosity with a like button smash. For more science that'll quench your thirst for knowledge, subscribe to Sci Sips. The adventure doesn't stop here. Hit that comment section below and tell us what cosmic mysteries you want to unravel next.
Can you believe that the ever-elusive feeling of happiness is actually a scientific phenomenon, intricately woven into the depths of our brain's complex maze? Oh yes, that warm and fuzzy sensation you get when you're content, that intense thrill when you accomplish your goal. It's not just vague or abstract, it's a solid physiological process. The puzzle of happiness, as it turns out, has its ringmasters dwelling right inside us. It's an exciting dance of neurotransmitters, our brain's chemical couriers, and specific brain areas that light up like a festival, responding to various stimuli, and even our unique genetic factors. Let's be clear, happiness is not just about the world outside, it's about the inner machinery of our brain. These elements unite, constructing a symphony of signals and responses, all leading to what we experience as happiness. So your cheerfulness is more than just feeling good, an intricate symphony conducted by your very own biology. Are you aware that your happiness is largely dependent on tiny chemical messengers buzzing around in your brain? Let us step into the world of these chemical couriers, the neurotransmitters, that play a pivotal role in your happiness. 3 key players in this fascinating game of mood regulation are dopamine, serotonin, and endorphins. Imagine dopamine as the brain's reward system. It's like a bountiful gift box that opens up when you achieve a goal or indulge in something you love.
The surge of dopamine brings about that sense of satisfaction and pleasure. It's the reason why you feel elated when savoring your favorite dessert, or when you hit a new personal best in your workout. Then we have serotonin, often dubbed the feel-good neurotransmitter. This chemical is like a soothing lullaby that helps maintain a balanced mood and contributes to feelings of well-being and happiness. Low levels of serotonin are often associated with mood disorders, including depression. Lastly, endorphins, the body's natural painkillers, often flood your system during intense physical activity, producing a feeling often referred to as the runner's high. They help to reduce discomfort, stress, and foster a positive and energizing outlook on life. Each of these neurotransmitters interacts with different parts of the brain, sparking off reactions that result in feelings of pleasure, satisfaction, and happiness. It's these microscopic wizards that hold the reins to your happiness. They are the architects of your joy. But can these chemical messengers be influenced? Can we consciously boost our happiness? These questions lead us to the building blocks of happiness: positive thinking, social connections, and having a purpose in life. Let's start with positive thinking. Our thoughts hold great sway over our emotions. A positive mindset can stimulate the production of serotonin, the neurotransmitter responsible for feelings of well-being and happiness. It's like having your own internal sunshine, brightening your mood from the inside out. Next, we have social connections. As humans, we're wired for connection. Relationships nourish us, providing a sense of belonging and mutual understanding. When we connect with others, our brains release oxytocin, often dubbed the love hormone. This neurotransmitter enhances our sense of trust and bonding, leading to increased happiness. Finally, having a sense of purpose plays a pivotal role in our happiness. Purpose gives us direction, a reason to wake up in the morning. It can stimulate the release of dopamine, our reward neurotransmitter. Accomplishing tasks aligned with our purpose gives us a dopamine hit, providing a sense of satisfaction and joy. These three elements, positive thinking, social connections, and purpose, can all stimulate the production of our happy neurotransmitters, thereby enhancing our mood and overall well-being. They are the building blocks of happiness, the foundation upon which we can construct a more joyful life. So your mind holds immense power. It can steer your neurotransmitters and thereby your happiness. Now that we've decoded the science of happiness, how can we use this knowledge to our advantage? Well, let's dive into some practical, evidence-based strategies to boost happiness. First off, cultivating a positive outlook is a powerful tool. By focusing on the good and embracing optimism, we can rewire our brains to produce more happiness-inducing neurotransmitters. Secondly, nurturing social relationships is vital. Our connections with others can stimulate the release of oxytocin, the bonding hormone, fostering feelings of happiness and well-being. Thirdly, finding purpose in life can significantly enhance our happiness levels. When we align our actions with our values and passions, we stimulate the reward centers in our brain, creating a sense of fulfillment. Lastly, practicing mindfulness allows us to live in the moment, reducing stress and promoting mental clarity. This helps to balance our brain chemistry and cultivate a more positive emotional state. Happiness, then, isn't just an emotion, it's a science, and you, my friend, are the scientist.
Forget everything you thought you knew about the world. Today, we're diving into the mind-bending realm of quantum mechanics, where particles defy logic and reality gets a major upgrade. Buckle up, because we're about to witness the impossible, electrons morphing into waves right before our eyes. For nearly a century, scientists have been chasing the ghost of the electron's wave nature, a theory whispered by giants of physics, but never truly seen. Until now. Get ready to witness the groundbreaking experiment that's shattering the boundaries of physics. We'll crack open the secrets of the Kapitza-Dirac Effect, a phenomenon where electrons dance a bizarre waltz between particle and wave. But hold on, there's more. This isn't just about cool visuals. This breakthrough could unlock the key to the future of technology, from ultra-fast computers to mind-blowing new materials. So, are you ready to peek into the quantum unknown? Let's unravel the mystery of the electron wave and see where it takes us. The dance of electron waves under the tune of light reveals a fascinating symphony of quantum mechanics, exemplified by the Kapitza-Dirac Effect.
First theorized in the early 20th century and observed decades later, this phenomenon showcases electrons scattering off of standing light waves, creating patterns that defy classical intuition. Recent advancements allow us not only to predict, but also to visualize these ethereal interactions with clarity once thought impossible. This vista into the quantum realm opens a doorway to manipulating the fundamental principles of nature in ways we are only beginning to understand.
The Kapitza-Dirac Effect, a cornerstone in the understanding of matter wave optics, was proposed by Piotr Kapitza and Paul Dirac in 1933. It predicts that a coherent beam of electrons can be diffracted similarly to light when passed through a standing wave of photons. This idea, audacious at its time, suggested that the wave-like nature of particles could interact with light not just as mere objects being illuminated, but as waves capable of interference and diffraction. For decades, the experimental validation of the Kapitza-Dirac effect remained elusive due to the technological limitations in generating sufficiently dense and coherent photon standing waves. However, the development of lasers in the 1960s provided a new hope, injecting momentum into experimental pursuits. The underlying quantum mechanics, predominantly guided by the Dirac equation, describes how waves of probability amplitudes, encapsulating positions and momenta of particles, evolve and interact in a quantized field. The theoretical leap from classical predictions to quantum mechanics opens up profound philosophical questions about the nature of reality, as particles exhibit characteristics of both particles and waves. Our conceptual understanding of electron diffraction through the Kapitza-Dirac effect bridges the gap between abstraction and perceptible phenomena, providing a vivid framework to explore the dual nature of matter.
The theoretical leap from classical predictions to quantum mechanics opens up profound philosophical questions about the nature of reality, as particles exhibit characteristics of both particles and waves. Our conceptual understanding of electron diffraction through the Kapitza-Dirac effect bridges the gap between abstraction and perceptible phenomena, providing a vivid framework to explore the dual nature of matter.
By the turn of the 21st century, leaps in laser technology and electron microscopy enabled scientists to not only observe, but also manipulate electron trajectories using light. The quest to visualize the Kapitza-Dirac effect culminated in a series of experiments that employed ultra-fast electron beams and intricately constructed laser setups, creating finely tuned standing waves of light to interact with electron waves. In pioneering studies, the use of attosecond laser pulses, lasting mere billionths of a second, allowed researchers to observe the interaction between electrons and standing light waves in real time. The lasers, coupled with advanced electron detectors that record arriving electrons at different angles and energies, provided unprecedented snapshots of this quantum ballet. Such phenomena are captured in novel imaging techniques that combine elements of both quantum and classical optics, offering a bridge between these realms.
The implications of these visualizations extend far beyond theoretical curiosity. They pave the way for developing advanced materials by manipulating electron distributions, potentially revolutionizing fields like semiconductor technology and nanofabrication. Furthermore, understanding the Kapitza-Dirac effect deepens our capability to harness quantum phenomena in computing, potentially leading to breakthroughs in quantum information processing where control over the phase and amplitude of electron waves is crucial. Here are some more mind-blowing facts about quantum mechanics. Electrons in an atom don't exist in a single point, but rather as a probability cloud, a wave spread out in space. We can only calculate the likelihood of finding them in a certain area. This mind-bending concept is called the wave function. This relates to the wave nature of electrons. In a famous experiment called the double-slit experiment, electrons were shown to diffract bend like waves, suggesting they could pass through both slits simultaneously. However, the act of observing them collapses the wave function, forcing them to behave like a particle and go through just one slit at a time. Quantum mechanics introduces a concept called entanglement, where two electrons become linked. If you measure the spin, a property, of one entangled electron, the other instantly has the opposite spin, no matter the distance between them. It's like they can communicate instantaneously, defying the laws of classical physics. However, entanglement doesn't allow faster-than-light communication, as you still need to send a classical signal, like light, to know the spin of the first electron. According to the Heisenberg uncertainty principle, it's impossible to know both the exact position and momentum of an electron simultaneously. This means an electron can borrow a small amount of energy for a very short time, seemingly violating the law of conservation of energy. However, the uncertainty is so small that it's undetectable in most situations. Understanding the wave-particle duality of electrons is crucial for developing technologies like quantum computers. These machines harness the strange properties of quantum mechanics to perform calculations that are impossible for even the most powerful classical computers.
The double-slit experiment is a classic demonstration of the wave-particle duality of electrons. Imagine firing electrons one by one at a barrier with two narrow slits. According to the classical view, particles, electrons would just pass straight through one slit or the other, creating two spots on a screen behind the barrier. However, the experiment shows an interference pattern, a series of bright and dark bands, on the screen. This is characteristic of waves diffracting, bending, as they pass through the slits. It implies the electrons behave like waves, spreading out and interfering with themselves. The Kapitza-Dirac effect connects to this idea in a fascinating way. Instead of a physical barrier, the Kapitza-Dirac effect uses a standing wave of light, created by two lasers interfering. Similar to the double slit, electrons interact with the peaks and the valleys of the light wave, again demonstrating wave-like behavior. They diffract based on the light's pattern, creating a specific deflection pattern. In essence, both experiments showcase electrons exhibiting wave properties by interacting with a specific grating, slits in one case, and a light wave in the other. This reinforces the idea that at the quantum level, particles can also act like waves, blurring the lines between the two.
The double-slit experiment and the Kapitza-Dirac effect throw a massive wrench into our understanding of the world. These phenomena scream wave-particle duality, implying that at the most fundamental level, particles like electrons can exist as probabilities and waves before collapsing into a definite state when observed. This challenges our everyday experience of a solid, predictable world. Is reality a simulation? This bizarre behavior pushes us to consider the very nature of existence. If the fundamental building blocks of reality can be both wave and particle depending on observation, could our entire perceived reality be a construct, a complex simulation like in the Matrix movies? Perhaps the act of observing collapses possibilities into a single reality we experience. It's important to remember that while the experiments are fascinating, they don't definitively prove we live in a simulation. However, they do open the door to a mind-blowing possibility. The beauty lies in the exploration. These experiments highlight the strange and wonderful nature of the quantum world. Perhaps the true answer isn't whether we live in a simulation, but the awe-inspiring mystery of how reality is truly constructed.
In conclusion, the visualization of the Kapitza-Dirac effect represents a quantum leap in our comprehension and manipulation of the quantum world. These experiments do not merely depict static scenes, but are dynamic glimpses into the fundamental workings of nature. They challenge our understanding, tempting us to think not only about what is possible in the present, but also about the endless possibilities that the principles of quantum mechanics may unlock in the future. This is just the beginning of decoding the complex symphony of electrons and photons, a narrative that continues to evolve as we delve deeper into the quantum enigma. Did that blow your mind? If you're still reeling from the wave-like wonders of electrons, smash that like button and subscribe to Sci Sips for more mind-bending science adventures. Let us know in the comments what other quantum mysteries you want to explore next.
Do you ever think about how some creatures illuminate the dark depths of the ocean with their own light? This striking phenomenon is known as bioluminescence, a captivating spectacle of biology that has intrigued scientists for centuries. Across the planet, a multitude of organisms exude this captivating luminescence. From the tiniest plankton to the enigmatic anglerfish, these creatures defy the darkness of their environment, becoming living lighthouses in the heart of the sea. The process of bioluminescence is a natural wonder, a chemical reaction within the organism that results in the production of light. Yet the details of this process are shrouded in mystery. How does this intricate reaction occur? What ingredients do these organisms use to create their radiant display? The answers lie within the biology of these fascinating creatures and the secrets they hold within their luminous bodies. Intriguing, isn't it? How do these creatures create light in the dark abyss of the ocean? Imagine a creature, a dweller of the deepest, darkest corners of the ocean, the anglerfish. This enigmatic creature, shrouded in mystery and darkness, is a master of a rare and beautiful phenomenon, bioluminescence. In the impenetrable blackness of the abyssal depths, where the sun dare not venture, the anglerfish illuminates its world. It uses a specialized luminescent organ known as the esca, located on a protrusion that extends above its mouth, much like a fishing rod. This glowing lure, a beacon in the void, is not just an accessory but a vital tool for survival. Now let's paint a picture. The anglerfish, lurking in the gloom, casts its radiant lure, creating an eerie spectacle of light in the pitch-black ocean. This luminescent display, a result of a chemical reaction within the esca,
is an ingenious strategy evolved over millions of years. It is a deadly trap, a tantalizing spectacle designed to attract the attention of any creature that might serve as a meal. The unsuspecting prey, drawn towards the mesmerizing glow, approaches the source, only to find itself in the jaws of the anglerfish. In the blink of an eye, the predator strikes, and the prey, ensnared by the allure of the glow, meets its end. This tale from the deep is a testament to the extraordinary adaptations life has developed in the face of extreme conditions. Here, in the depths where sunlight is a foreign concept, the anglerfish has harnessed the power of light, transforming the darkness into a hunting ground. Bioluminescence, this marvel of nature, is not just a spectacle to behold, but a survival mechanism, a weapon, and a tool. It is a testament to life's relentless ingenuity, its ability to adapt and flourish even in the harshest of environments. The anglerfish is just one of many examples of how nature has harnessed the power of light in the most unlikely of places. So, how does this fascinating phenomenon of bioluminescence work, you might be wondering? Well, let's delve into the captivating world of biochemistry to illuminate this subject. Bioluminescence, the ethereal glow emitted by certain organisms, is a result of a chemical reaction that happens within their bodies. This reaction involves two key players, a molecule known as luciferin and an enzyme called luciferase. The luciferin is the star of the show, the substance that emits light when it undergoes a chemical reaction. The luciferase, on the other hand, is the director, the catalyst that accelerates this reaction. When these two components come together in the presence of oxygen, a reaction takes place, releasing energy in the form of light. This light can range from blue to green, and sometimes even red, depending on the specific type of luciferin and its reaction conditions. Now, the color of the light emitted is not a random spectacle, but a highly specific outcome. Different organisms have different types of luciferin-luciferase systems, which result in the emission of different colors of light. For instance, the spellbinding blue glow of certain jellyfish is due to a specific type of luciferin called coalenterazine, while the enchanting green light of the firefly is due to another type of luciferin. Moreover, the color of the light can also be influenced by additional factors, such as proteins that the organism might produce. These proteins can interact with the light-emitting reaction to shift the color of the emitted light, further adding to the diversity of colors we see in bioluminescent organisms. This intricate play of chemistry and biology, of luciferin and luciferase, of light and life, is what lies at the heart of bioluminescence. It is a testament to the ingenuity of nature, a radiant example of how life has evolved to harness the power of chemistry to create light. Bioluminescence, hence, is not a mere spectacle of light, but a complex, well-orchestrated symphony of chemical reactions. And what if I told you that this incredible phenomenon has potential applications in science? Yes, the enchanting spectacle of bioluminescence has more to offer than just a breathtaking light show. It may sound like a tale spun from the threads of science fiction, but the reality is even more fascinating. Let's explore the potential human applications of bioluminescence. Picture this: medical diagnostics enhanced by the glow of life. Bioluminescent proteins can be engineered to light up in response to specific biological conditions, offering a vivid, visual confirmation of disease presence. How about illuminating the path of drug discovery? Bioluminescence can be applied to monitor the effectiveness of drugs in real time, revolutionizing the field of pharmacology. Now, imagine a world where pollution is not just an invisible enemy. With bioluminescent bacteria that respond to toxins, we could create a real-time pollution detection system, painting a glowing map of environmental health. This could enable us to react swiftly, mitigating the damage and protecting our precious ecosystems. But the applications of bioluminescence don't stop there. What if the soft, ethereal light of bioluminescent organisms could light up our homes and cities? This may seem far-fetched, but research into bioluminescent lighting solutions is ongoing, driven by the dream of sustainable, energy-efficient illumination. The importance of continued research in this field cannot be overstressed. It is the beacon that guides us towards these remarkable applications, illuminating the path of scientific progress. Each glow in the deep sea is a spark of inspiration, a testament to nature's ingenuity, and a reminder of the untapped potential that lies beneath the waves. The glow of the deep sea may very well illuminate our future in ways we can scarcely imagine. As we delve deeper into the secrets of bioluminescence, We are not just exploring the mysteries of the ocean, but also lighting up the path of human innovation and progress.
Hey, Sci Sippers!
What's up, science enthusiasts?
We have been listening to your comments and suggestions closely.
Buckle up, because things are getting a shake-up on the Sci Sips channel. We are expanding our team of AI narrators.
We're excited to introduce a brand new format, multiple narrators.
That's right. Now you'll get different narrators on the same fascinating science topics.
From experts breaking down complex concepts
to passionate science communicators igniting your curiosity.
We're bringing you a richer, more engaging way to explore the wonders of the universe.
Think of it like a science summit right here on your screen.
This means you'll get a deeper understanding, diverse viewpoints,
and maybe even a healthy dose of friendly debate.
Smiling, we're always looking for ways to improve the quality of the content we bring you.
So, let us know what you think.
Hit that like button if you're excited about this new format, subscribe for more, and leave a comment below telling us what science topics you'd love to see tackled with multiple narrators.
Thanks for joining us on this scientific adventure.
Let's get sipping on some science.
Before we go, though, what's Sci Sips all about?
Science enthusiasts, hello! Welcome to Sci Sips, your one-stop shop for making science fun and accessible. Whether you're a curious student, a lifelong learner, or just someone who wants to impress your friends at a party, Sci Sips has something for you.
We break down complex scientific concepts into easy-to-understand chunks, with bite-sized videos and engaging explanations.
But it's not all lectures here. We've got fun experiments, mind-blowing facts, and even some friendly scientific debates to keep things interesting.
So, join our vibrant science community. Subscribe for new videos, hit that notification bell, and leave a comment below letting us know what kind of science content you'd love to see next.
Because at Sci Sips, the only limit is your curiosity.
Alright, Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.